Okay, so now actually it is the last problem of our sample two of the final exam, problem 7. It is about friction. So typically this kind of problem composed of two parts. So the first part is actually asking what is a condition to keep the block to be there. Okay, so the second part will be, so typically we assume the object is in equilibrium and we can solve the friction that we need, and then it will ask us, will the block move or stand still? Okay, so now let's start from the first part. So it asks us to determine the minimum uh, constant of the static friction, mu s here, will just keep the block from slide. Okay, so how can we approach that? So we know that when we have the condition saying that it's just to keep the object to move, that means our friction is the friction reach is my maximum, right? That means if we have a condition change a little bit to further facilitate the block to move, then it will move. So that implies that we have our friction here. Okay, so friction, the small f equals to mu s normal force here, right? Okay, so now we will have we we will have, okay, so if we see that the object is can be kept from slide, meaning that it is still in equilibrium, and we can evaluate that. So the first step for force analysis, it is actually okay. So it is actually so it will be free body diagram, right? So free body diagram, and the free body diagram of the object is so what forces do we have on the object it will contain? So first we have a gravity, right? We have a gravity here. Good. So it is 40 pounds. And we have external force, right? So we have the external force here, which is actually 20 pounds. And in addition to that, we have the support normal force here, right? And then our friction. So the direction of friction is opposite to the external force because it is trying to cancel that out to keep our block to stay there, right? It is the free body diagram. Okay, so now we can establish. So now the next step is equations of equilibrium. So first, summation of forces on x direction equals to 0, right? Okay, so we have along x direction, we have external force going to the right, right? It is a positive here. And we have a friction here going to the left, right? So it is a negative here. And it is a negative mu s n here, right? Okay, and it equals to 0. And by seeing that it's mu s n, we admit that it is so the block is about to move. So it is a limited state. So okay, and for our y direction, the summation of all forces along y direction equals 0. And we have the normal force going upward and the gravity going downward. So going downward is a negative here, equals to 0, right? Okay, so now we have, from the equations, we have the normal force equals to 40, right? It's just equals to just equals to the weight. And we have then, well, by the first equation, we have mu s equals to 0.5, right? So that means we have to have at least mu s equals to 0.5 to just keep the block from slide. If we have the mu s smaller than this value for a little bit, so the block will start move. Okay, so this is the first question here, and for the second question here, this require us to determine the friction force that plane exerts on the block. Okay, if the external force equals to 30 pounds, and if the constant of the static friction is 0.65 here. So okay, so now again we're going to check that. So first, again, we are going to perform force analysis for the object. And for the first for the force analysis for the object, the first step is free body diagram. But we are going to see that the free body diagram is almost the same. The object, okay. So external force, now it's changed to 30. Gravity, 40. Friction, again, it is opposite to the external force. Normal force N. Okay. So now, second step, equations of equilibrium. Equations of equilibrium here. And now we have along x direction, we have 30 pound, and it is going to the right, so it is a positive here. Friction, it is going to the left, so it is negative here, right? Equals 0. Okay, now please note that so the problem didn't say that it is so the block is about to move. So we cannot say that we know that the friction equals to mu s n here. So because the friction here can be smaller than that, right? Okay, so now the friction have to be determined by the equation of equilibrium. Okay, so secondly, we have the summation of forces along y direction equals 0, and along y direction we have n going upward, gravity going downward. It is completely the same as previous, right? Okay, so now by the two equations we have the normal force equals to 40 pound, and the friction equals to 30 pound, right? Okay, so now the friction is actually 30 pound here. Okay, so the problem asking is the block is about to move. Well, okay, so we are going to check that. If the friction that we need is 30 pound here, then yeah, on another hand, so the maximum friction that we can provide is equals to mu Sn, which is actually 0.65 times the normal force, right? It equals to, okay, so we have that equals to 26 pound. Oh, well, it is actually smaller than, it is actually smaller than the force that we have, right? So now the question here is that will the object start to move? Yes, right. So in that way, we have to correct the friction force to be actually the maximum force that it can have. Okay. So it is a maximum friction that my surface can provide. So it is also the force that when we at the moment that we are analyzing the object, so will it so the friction that exerted by the surface. Once the object start to move, the friction will decrease to kinetic friction here. So this is pretty important to know here. Okay, so it is a maximum friction that the surface can exert. Okay, so now it is actually the last problem here. So the last problem is about friction, and so for the problem 7, the last problem here. So the first part asks us to determine the minimum constant of static friction that the surface should have to keep the block to be there. And in that case, first we are going to have force analysis, right? And by performing force analysis, we also know that since we are analyzing the block when it is about to move, so we have the friction equals to mu Sn. That means we assume that the friction reaches its maximum here. But when it comes to the second part, so we are required to determine the friction that the plane exerts on the block. And we also require to judge with the block move here. So again, it is a force analysis, but in that case, we are not sure if the block is going to move. So we cannot assume that the friction is directly equals to mu Sn. So the friction could be smaller. Well, so the friction now becomes an unknown, and we have to determine that by the equilibrium. And the friction that determined by the equilibrium is actually the friction that we need to keep the block to be there. Okay, so now we are going to compare the friction that we need to the maximum friction the surface can provide. So now for this specific problem, we see that the maximum friction that the surface can provide is smaller than the friction that we need. So the friction exerted by the plane will be so the maximum friction that the surface can provide, right? Okay, so in other words, so my surface cannot provide more. Okay, so this is pretty important, and due to the maximum friction is smaller than the friction that we need, so the block will move. So it is so the answer for whether the block is going to move is yes here. Okay, this is a little bit tricky.